Chapter 1 Real Numbers Part 5. So we are going to see in Part 5 revisiting real numbers and their decimal expansions. Revisiting real numbers and their decimal expansion. Real number means you know already two types you have. Rational numbers, irrational numbers. So rational numbers and the irrational numbers are called real numbers. Okay, in 9th class also you studied. Okay, 10th class also I explained earlier. So the decimal expansion you have in two types of rational numbers. There are two types decimal expansion. You see the first one, terminating decimal expansion. Terminating means what? Ending. Terminating means ending. Example you see first one 0.5. 0.5 can be written as 1 by 2 in the P by Q form. Clear? Second one is 0.009375. It can be expressed in the form of P by Q is 15 by 16,000. Clear? That will be factorized. It means 15 by 2 power 6 into 5 power 2. You can factorize means correctly we will get 2 power 6 into 5 power 2. Okay. 16,000 you factorize. Clear? Now you compare these two. See, when the decimal expansion terminates, then Q must be in the form of a 2 power n into 5 power m. Clear? From this what you will understand, you see the denominator always in the form of 2 power n into 5 power m means then it terminating. Clear? Terminating decimal. Understand? Clear? So it terminates means definitely Q must be the form of 2 power n into 5 power m. That is conversely also it is true. Conversely also it is true. Q must be 2 power n into 5 power m means then definitely it will terminate. The decimal expansion will terminate. Or terminating decimal always clear. Q must be 2 power n into 5 power m. Okay. Terminating decimal you express in the form of P by Q means Q must be 2 power n into 5 power m. That is the rule you have to remember. Okay. That is a condition you have to remember. Clear? Then second, non-terminating and repeating decimal expansion. Rational numbers into two types. One is terminating decimal expansion. Another one is non-terminating and repeating decimal expansion. So example you see 3.333. Okay, it is going on. Never ending. Okay, non-terminating means what? Never ending. At the same time, decimal is what? Repeating. Decimal is repeating. So this can be written as 10 by 3. 10 by 3 you divide, you will get this. Okay, in lower class also you have studied this. Right? Ordinary division you do, you will get this. Okay. Then second one, you see 0.05555 like this it is going on. So it is also decimal is what? Non-terminating and at the same time 5 is what? Repeating on. Clear? So it is non-terminating and repeating decimal expansion. This is nothing but 1 by 18. This is nothing but 1 by 18 in the P by Q form. We can also what easily express it in the form of P by Q. Clear? In 9th class also you studied this. Clear? How to express the form of P by Q. Clear? The given decimal numbers. Okay. So this 18 can be written as 2 into 3 power 2. 18 can be written as 2 into 3 power 2. Now you see the denominator. Both number denominator you see. Q is not in the form of 2 power n into 5 power m. Okay. Here 3 is there. 3 factor is coming. Of course 2 is there. But 3 is coming. You should be only 2 power n into 5 power m. But here you are getting 3 also. So that it is not in the form of 2 power n into 5 power m. Okay. Therefore, the decimal expansion is non-terminating and repeating. Clear? Decimal expansion is non-terminating and repeating here. Understand? So both way it is true. Q is not in the form of 2 power n into 5 power m means you can immediately say what the decimal expansion is non-terminating and repeating. Okay. Q is in the form of 2 power n into what 5 power m means you can say decimal expansion is terminating. Clear? Then you come to irrational numbers. Already you know irrational number means what? It cannot be expressed in the form of P by Q. Therefore, in the decimal expansion means non-terminating and non-repeating decimal expansion. Non-terminating and non-repeating. Clear? That means example you see 0.10, 110, 1110, 11110 it is going on. So never ending. Non-terminating, never ending, at the same time non-repeating also. Okay, here you see one number is repeating, some group of number is repeating, but here it is okay, it is not at all repeating. Okay, no group is repeating here. Second one also 7.07, 007, 0007, it is going on repeating. Therefore, it cannot be expressed in the form of P by Q. Clear? It cannot be expressed in the form of P by Q. Clear? So here there is two conditions you have to remember that. That is Q is not in the form of 2 power n into 5 power n means the rational number in the decimal expansion is non-terminating and repeating decimal. Okay, Q is in the form of 2 power n to 5 power n means the rational number, okay, in the decimal expansion is terminating. Clear? So this is the main idea. Always in this chart you have to remember means clear. Easily you can solve the problems. It is very important. Okay. Work with this. You see in your textbook it is given theorem 1.5. Theorem 1.5. This is the example. Okay. Same thing only. Okay. Theorem 1.5 statement only given. Clear. The result is same thing only. Okay. Theorem 1.6, the result is same only. Then theorem 1.7. Okay, on seeing your textbook, you write the statement and see this example. Easily you will understand the theorem. Okay. Next, we will see the exercise 1.4. First question you see. Without actually performing the long division, state whether the following rational numbers will have the terminating repeating decimal expansion. Okay, we have terminating repeating decimal expansion. Okay, we have to find out. So we have to see the denominator. Okay, without using long division method. So how to check means the denominator, that is Q, must be in the form of 2 power n into 5 power m. We have to check. Clear? So for that you see the denominator 3125 is the denominator. Here you have to check how to find out the factors means just what division method, that is okay. It will go in 5 table. It will go in 5 table. So 31 6 10 remainder 1, so 2 12, so 5 again 5 table it will go 1 time 2 time 5 time again 5 table, then 25 again 5 table. Okay. Therefore, this denominator can be written as this denominator 3125 is nothing but 1, 2, 3, 4, 5. So 5 power 5. 5 power 5. Clear? Now you see Q is in the form. Q is in the form of 2 power n into 5 power n. Okay, Q is in the form of 2 power n into 5 power n. Clear? Here actually what 2 power not there. You can add into 2 power 0 you can keep. Clear? Because n and m are integers. Clear? That's why 2 power 0 also into 2 power 0 you can write. Clear? So Q is in the form of 2 power n into 5 power m. So Q is in the form of 2 power n into 5 power m. So n and m are non-negative integers. In the theorem it is given. N and m are non-negative integer means positive integers. It may be 0 also into 2 power 0. You will get the form, right? That's all. Where non-negative integer means 0 is also an integer. Then positive integers. Okay. Get this form. Okay, therefore the decimal expansion is terminating. The decimal expansion is terminating. When you get the form 2 power n to 5 power n, then decimal expansion is terminating. So when it is terminating, you can find out the decimal expansion also, okay, without actual division. Clear? You see, when it terminating, you can find out the decimal expansion. Then how to find out the decimal expansion means, that is they asked in the second problem. Okay, second problem continuation. This one. Okay. So here this can be written as, you see, this can be written as 3 into, clear, 2 ka 1 you write. The second problem they asked what? Decimal expansion. Write the decimal expansion if the decimal expansion terminates. Clear? That's why I am doing a second ka 1 also here itself. Okay. So 3 into, this can be written as 5 power 5 into, here you see what 2 is not there. You have to what? Make 2. Why you have to make what? 2 powers means denominator you have to get tens. Denominator what? You have to get tens means, clear, easily you can do. That's why here 5 power 5 is there. So you multiply 2 power 5 by 2 power 5. Okay, that is equal to 3 into 2 power 5. Numerator and numerator multiply. The denominator you see 5 power 5 into 2 power 5 is what? 5 into 2 whole power 5. So into 25. Oh sorry, 2 power 5 is 32. So 2 power 5 is 32. Here 10 power 5. So 10, you got it. Clear? The denominator, see, you have to make the denominator 10 powers. For that here 5 already there means 2 you have to multiply. That's all. That is the technique. Okay. So here now 3 into 32, 696 by 10 power 5. Right? 10 power 5. 10 power 5 means 1 is followed by 5 zeros. So here already 2 what? 2 digit there. So we need 3 more digit. Okay, you add 3 more digit, keep the point. 3 more 0 you add, then here keep the 6, 9, right? Then 3 more 0 you add, keep the point. That's why 10 power 5 denominator means after decimal 5 digit it should be, right? After decimal 5 digit it should be, but here 2 only there. So you have to add 3 more. Okay. Now you see the decimal expansion is what? Terminating exactly. Okay. When it terminates means you will get in the form 2 power n into 5 power n. Means definitely it will terminate. Because easily we can make the denominator what? 10 powers. Clear? 10 powers. Then easily we can find out the decimal expansion. Clear? Okay. This is now next to problem 17 by 8 you will see, right? 17 by 8. How to do is already denominator you see 8 is there. 8 is nothing but 2 power 3. So 17 by 2 power 3. Therefore, this implies what? Q is in the form of 2 power n into 5 power m. 2 power n into 5 power m, where m and the n are also non-negative integers. Where n and the m are non-negative. Where n and m are non-negative integers, right? So Q is in the form, you got it, okay? Therefore, how the decimal expansion is, so it is terminating decimal, it is terminating decimal, or the decimal expansion is terminating decimal expansion, it is terminating decimal. When you have 2 power n into 5 power m denominator means definitely it is terminating decimal. Clear? The decimal expansion is terminating. Anyway you can tell. Therefore now you have to find out the in the form of what? Decimal. So how to find out means you take this. That is second problem, second one. So 17 by 2 power 3 you take. That is equal to, here 2 power 3 is there. Okay, you have to make what? Tens power means here you have to, how much you have to multiply mean 5 power 3. 5 power 3 by 5 power 3. Clear? 2 power 3 is there. So 5 power 3 you have to multiply. That means 17 into 5 power 3 means 125. Right? Decimal expansion. So 17 into 125. You multiply it, see, 2125. Okay, 2125. So 2125 numerator, denominator 10 cube means 1000. So divide means 3 digit you leave it and keep the point. That is 2.125. That is terminating decimal. Decimal expansion is for terminating. Okay, so we got the second problem, second one also. The second problem they asked you to do, write the decimal expansion. This is decimal expansion, right? For this problem. The next problem, 64 by 455, right? So for denominator you factorize first. Always denominator you have to see, okay? 5 table it will go. 9 times, 9 5s are 45, then it will be 1 time. So 9 it will go in 7 table. 7 table it will go, right? 1 time, then 3 times. 1 time 7 to remainder 2, 21, 3 times. That's all prime number. Denominator you are getting for all prime numbers. 5 into 7 into 13. So on seeing the denominator, what you can say? Cube is not in the form of 2 power n into 5 power n. Clear? Cube is not in the form 2 power n into 5 power n. So not in the form means then what is the decimal expansion? So it is non-terminating and repeating decimal. Non-terminating and repeating decimal, that's all. So in the second problem, non-terminating and repeating decimal, you no need to find out the decimal expansion. Clear? Only for terminating only they asked the second problem. So in the second problem we'll see fourth one, 15 by 1600, right? So 1600 you have to do factor. So 2 table 800, again 2 table 400, again 2 table 200, again 2 table 100, again 2 table 50, again 2 table 25, again 5 table, here 5. So how many 2 there? 1, 2, 3, 4, 5, 6. So this 1600 can be written as 2 power 6 into 5 power 2. Okay. So exactly you are getting the form 2 power n into 5 power n. Therefore cube is in the form. In the form of 2 power n into 5 power n. Therefore it is terminating decimal. So terminating decimal means easily we can find out the decimal expansion. You see, decimal expansion easily we can find out. 2 power 6 to 4. Okay. That is second problem ka fourth one they asked what? Find out the decimal expansion if terminating decimal. Clear? Now very simple, you see. Here 2 power 6 there, but here 5 power 2 is there. So you have to make, this is also what, 5 power 6. The power should be what, the same you have to make. So that what, here remaining 5 power 4 you have to multiply and divide 5 power 4 by 5 power 4. So that is equal to 15 into 5 power 4. 5 power 4 is 625. 5 power 3 is 125 into 5, that is 5 power 4, 625. Okay. Now in the denominator you see 2 power 6. Then this is 5 power 2, 5 power 4 means 5 power 6, right? that is equal to, now you multiply 15 into 625, 15 into 625. So 15 into 625, 9375, right? Divided by 2 power 6 into 5 power 6, 10 power 6. 10 power 6. So 10 power 6 means what? 6 digits. So after decimal you should have how much? 6 digit, but already 4 digit there. So you have to keep 0.2 more digit we need. So add 0. Okay, then you write that 4 digit. Clear? So now easily we can find out the decimal expansion. Clear? When it terminates. Understand? Next, fifth one, 29 by 343. You see 343, you divide by which table will go? 3 table will not go. So 7 table it will go, I think. Okay. 7 table, how many time will go this? I think 4 times, 28. Then 63 means 9 times, yes. 7 into 7. So this is equal to 29 by 7 cube. But 7 cube is there. So denominator you are not getting in the form of 2 power n into 5 power n. Therefore, cube is not in the form of 2 power n into 5 power n. Therefore, this implies what? It is non-terminating and repeating decimal. It is non-terminating and repeating decimal. Or decimal expansion is, you can write like that also. Decimal, therefore decimal expansion is non-terminating and repeating. You can write like that also. Okay. Next we will see 8th problem. Okay. 6 by 15. So see the denominator. 6 by the 15 is how the 15 is 3 into 5. Alright. 3 into 5. So immediately you should not write 3 into 5 is not in the form of clear 2 power n to power n, because here common factor is there. Here also 6 can be written as you can cut means 2 will get. So this is nothing but what? 2 by 5 only. So 2 by 5 only. So Q is, now you see Q is in the form of 2 power n into 5 power n. Clear? Therefore Q is in the form. Q is in the form of 2 power n into 5 power n. Okay. Therefore, it is terminating. It is terminating decimal. Terminating decimal. Clear? Therefore, terminating decimal easily you can find out. Okay. So 2 by 5. How will you write 2 by 5? 2 by 5 equal to 2 by 5 into, here we need what? To make 10 means you need 2 power 1. So 2 into 2 or 2 by 2 multiply. So 2 into 2 is 4. So 4 by 10, that is equal to 0.4. 0.4. So decimal expansion is terminating, right? This is 2 ka 8. That's all. Clear? So next problem, third problem we will see. Okay. The following real numbers have decimal expansions as given below. Decimal expansion given below. In each case, decide whether they are rational or not. First, you have to find out whether it is rational number or irrational number. Then, if they are rational number and you have to write in the form of P by Q, then what you can say about prime factors Q? You have to find out the prime factor of Q. Clear? So, first you see, on seeing this problem 43.12345 terminating. So, it is a rational number or irrational number. So clearly it is rational number. Clear? It is rational number. Therefore, it is terminating decimal. Terminating decimal. Therefore, it is rational number. Rational number. Okay. When it is rational number, you can write easily in the form of what P by Q. P by Q form you can write. So this can be written as, therefore 43. So how many decimal there after point? How many decimal is it? 1, 2, 3, 4, 5, 6, 7, 8, 9 there. Okay. So you remove the decimal. Divided by 10 power 9. 10 power 9. Clear? Now this 10 can be written as 10 is nothing but what? 5 into 2, right? 5 into 2. So 2 power 5 into 2 power 9 into 5 power 9. 2 power 9 into 5 power 9. Clear? Therefore, you got the what? P by Q form. In the denominator, Q is, therefore Q is 2 power 9 into 5 power 9. The prime factor. Okay. So prime factors Q is 2 power 9 into 5 power 9. So next problem is 0.1200120012001200. That means what? It is non-terminating and non-repeating also. It is non-terminating and non-repeating. Non-repeating decimal. Okay, non-terminating, non-repeating decimal means definitely it is what? Irrational number, not rational number. Therefore, it is irrational number. It is not rational number, it is irrational number. So it is clearly what? Non-terminating and repeating. You see, this group is bar given means what? This group is repeating. Clear? Therefore, it is non-terminating and repeating. Repeating decimal. Therefore, it is rational number. Therefore, it is rational number. So, rational number. How denominator, the Q is in the form of 2 power n into 5 power m. Therefore, Q is not in the form of the form of 2 power n into 5 power n. Okay, other than you will get 3, 9 like that you will get. Okay, so easily you can find out also this. Understand? So I will give some homework problem. Clear? At the end of the video, you do practice.